You know, we spend a lot of time talking about horsepower. We love big V8s, screaming V12s, and even those zippy little four-cylinders with turbos. We obsess over 0 to 60 times and how much power we're putting to the wheels. But what about the parts that make all that performance possible? I'm talking about the unsung heroes, the guys working behind the scenes. And one of the most important, yet often overlooked components under your hood is the radiator. It's the bouncer of your engine's club, making sure things don't get too hot and out of control. Without it, that glorious engine you love so much would turn into a very expensive, very stationary paperweight in just a few minutes. So how does this thing work? It's actually a beautifully simple piece of engineering. Think of it like this. Your engine is a furnace, constantly creating heat from all those tiny explosions in the cylinders. That heat has to go somewhere. A special fluid called coolant or antifreeze gets pumped through passages in the engine block, absorbing all that intense heat. This super hot coolant then travels through a hose to the radiator. The radiator itself is a network of tiny tubes surrounded by even tinier fins, like a metal honeycomb. As the hot coolant flows through these tubes, air rushes past the fins, either from the car moving or from a fan, and pulls the heat away. It's just like blowing on a hot spoonful of soup to cool it down. Once the coolant has made its journey through the radiator and shed all that excess heat, it's ready to go back to work. It flows out of the radiator through another hose and heads right back to the engine to pick up another load of heat. This continuous loop is what keeps your engine operating at its ideal temperature, usually somewhere around 195 to 220 degrees Fahrenheit. It's a constant cycle of hot in, cool out. This process is absolutely critical. If the system fails, temperatures can skyrocket, leading to warped cylinder heads, blown gaskets, and a repair bill that'll make your wallet cry. So next time you pop the hood, give a little nod to that radiator. It's doing a tough job. The entire system is a marvel of thermal dynamics, working tirelessly every time you turn the key. It doesn't matter if you're driving a brand new hypercar or a 100-year-old classic from my collection, the basic principle remains the same. The engine gets hot and the radiator cools it down. It's the difference between a pleasant Sunday drive and being stranded on the side of the highway with steam pouring out from under your hood. And believe me, I've been there. Understanding how this crucial part works is the first step to appreciating the incredible engineering that goes into every single car on the road. It's a true workhorse and it deserves our respect. Now, not all radiators are created equal. They come in a few different designs, but the two main types you'll hear about are downflow and crossflow. The names tell you pretty much everything you need to know about how the coolant moves through them. The older style, which you'll find in a lot of classic cars, is the downflow radiator. In this design, the coolant enters a tank at the top, gravity helps pull it down through the core's vertical tubes, and it exits from a tank at the bottom. Think of it like a waterfall. It's a simple, effective design that got the job done for decades. You'll see these in everything from a Ford Model T to a 1960s muscle car. These downflow radiators were great for their time. They were tall and narrow, which fit perfectly in the engine bays of older vehicles where you had plenty of vertical space. The radiator cap, which is also a pressure relief valve, is usually located right on the top tank, making it easy to access. However, as cars started getting lower and more aerodynamic, designers needed to change things up. The tall, upright stance of a downflow radiator just didn't fit with the sleek, low hood lines of cars from the 70s, 80s, and beyond. Engine bays were getting more crowded and real estate was at a premium. A new solution was needed for a new era of automotive design. Enter the crossflow radiator. This is the design you'll find in almost every modern car today. Instead of top and bottom tanks, a crossflow radiator has its tanks on the sides. The coolant enters one side, flows horizontally across the core, hence the name crossflow, and exits out the other side tank. This allowed engineers to make radiators that were much shorter and wider. This was a game changer. Suddenly you could have a much lower hood line, improving aerodynamics and giving cars that aggressive, sleek look we've all come to love. It was a perfect fit for the changing face of automotive styling. Besides just fitting better, the crossflow design also has some performance advantages. Because the coolant travels horizontally, the radiator cap can be placed on the low pressure side, which is often a separate expansion or overflow tank. This makes the system more efficient at handling pressure. Also, the wider design often allows for a more efficient core, giving it better cooling capability in a more compact package. So, while the downflow radiator served us well for many years, the crossflow design was a necessary evolution. It helped shape the look and performance of the modern automobile, proving that even something as simple as a radiator can drive innovation. Just as the design of radiators has evolved, so have the materials used to build them. For the longest time, the go-to materials were copper and brass. If you look at a radiator from one of my Duesenbergs or an old Bentley, you'll see this beautiful, heavy, all-metal construction. Copper is a fantastic conductor of heat, which is exactly what you want. The core tubes were made of copper, and the fins and tanks were made of brass, which is an alloy of copper and zinc. These things were built like tanks. They were also repairable. If you got a leak, a good radiator shop could solder it right up and have you back on the road. There was a downside to all that copper and brass though. First, it's heavy. Really heavy. And in the world of cars, especially performance cars, weight is the enemy. Every extra pound you carry around is a pound your engine has to work to move. Second, it's expensive. As the price of copper went up over the years, manufacturers started looking for a cheaper, lighter alternative. The maintenance was also a factor. While repairable, these older radiators were prone to corrosion if you didn't use the right coolant, and those repairs, while possible, required a skilled hand. The industry was ready for a change. That change came in the form of aluminum. Starting in the 1980s, you began to see more and more cars rolling off the assembly line with aluminum radiators. Aluminum is incredibly lightweight compared to copper, a huge plus for performance and fuel economy. It's also very strong and resistant to corrosion. While it's not quite as efficient at transferring heat as copper is, engineers found ways around that. They developed new manufacturing techniques, like brazing, that allowed them to create aluminum radiators with more efficient fins and tube designs, making up for the material difference. The result was a radiator that was lighter, cheaper to produce, and cooled just as well, if not better. Today, the most common setup you'll find is a hybrid, an aluminum core paired with plastic side tanks. This is the best of both worlds for mass production. The aluminum core provides excellent lightweight cooling, while the plastic tanks are incredibly cheap and easy to mold into complex shapes, which is great for fitting them into tight modern engine bays. The downside? They aren't really repairable. If a plastic tank cracks, you just replace the whole radiator. For a daily driver, this is fine. But for classic restorations or high-performance builds, many enthusiasts, myself included, still prefer the durability and classic appeal of an all-metal, fully welded aluminum, or even a traditional copper-brass radiator. To really see this evolution, you just have to look at the cars. Take a classic American muscle car, like a 1969 Chevrolet Camaro, pop the hood, and you'll likely find a big black downflow radiator made of copper and brass. It's tall, it's heavy, and it sits right up front, fed air by a large engine-driven fan. It was state-of-the-art for its time, and it did a decent job of keeping that big block V8 cool during a drag race, but it could struggle in stop-and-go traffic on a hot day. The technology was simple and robust, designed for the packaging and power levels of that era. It was all about vertical space and brute force cooling. Now let's jump forward a few decades to a modern performance car, say a new C8 Corvette. The story is completely different. First off, you won't find just one radiator. With its mid-engine layout, the C8 uses two smaller cross-flow radiators, one mounted on each side at the front of the car. They are made almost entirely of aluminum with plastic tanks. They are short, wide, and angled to maximize airflow coming through the front fascia. Instead of one big engine-driven fan, they use powerful computer-controlled electric fans that only run when needed, saving horsepower and improving efficiency. It's a sophisticated system designed for a completely different kind of car. The contrast between these two examples is stark, and shows just how far radiator technology has come. The Camaro's radiator is a standalone, mechanical component. The Corvette's radiators are an integrated part of a complex thermal management system that interacts with the car's aerodynamics and electronics. The materials have shifted from heavy repairable copper to lightweight, disposable aluminum and plastic. The design has flipped from a vertical downflow to a horizontal crossflow to accommodate low aerodynamic hood lines. Everything has been optimized for weight, efficiency, and packaging in ways engineers in the 1960s could only dream of. So, why does any of this matter to you, the car enthusiast? Because understanding the radiator is understanding a key piece of your car's performance puzzle. Knowing the difference between copper and aluminum helps you make the right choice when restoring a classic or upgrading a modern car. Recognizing the signs of a failing radiator can save you from a catastrophic engine failure. It's a reminder that horsepower is only half the story. The other half is about managing the incredible heat that power creates. So the next time you're at a car show, take a moment to look past the shiny chrome and appreciate the humble radiator. It's the cool-headed hero that makes all the hot rodding fun possible.